Hello everyone. So I hope you are all doing well. Now in this particular lecture, we'll try to learn what is interpolation, extrapolation, and what are the different operators and relation between them. So let us first take a function y equals to f of x. So we have taken a function y equals to f of x. So here x is independent. Okay, x is independent variable and y is dependent on x. So means we can choose any value in place of x, but y is dependent on that particular value of x. So that's why it is called dependent variable. Now let us take some values of x naught, then x1, x2, and xn. So we have taken some values, n values, n plus 1 values, different values of x. Now the function is y equals to how much? F of x. So whenever you put x naught, our function will become f of x naught, or you can say y naught. Similarly, if we put x1 in the function, our function will become f of x1 or y1, then f of x2, y2. So in the same way, if we put xn, our function will become f of xn, or you can denote it by yn. So these values, no, the values of y are called entries. Okay, whatever values of y you will get after putting some different values of x, those values of y are called entries, and the values which we are taking or putting in place of x are called arguments. Okay, these are arguments. So we have taken a function y equals to f of x, and then after that we choose some values of x, those are called arguments, and the corresponding values of y are called what? Entries. Okay, now let us okay. So the function is what? Y equals to f of x. Now our starting number is x naught, and the ending number is what? Xn. And in between we have some other numbers x1, x2, like this xn. Now we are seeing n plus 1 number x0, x1, x2. But see, in between x0 and x1, we have some other values also, right? There are some other real numbers or rational number. So in between x0 and x1, we have some other values. Similarly, in between x1 and x2 also we have values. So in each subinterval, this is one subinterval, this is another subinterval. So in each subinterval, we have some more values. So we are getting the values of y for this particular points x0, x1, x2. But what about the other values? So if someone want to find the value of y in suppose we want to find y equals to f of x for any x which lies between x0 and x1. Okay. So x0 our starting number, x1 is the second number of the of that range x0 and xn. So suppose we want to find the value of x for any value in between x0 and x1. So if we want to find the value of the function y equals to f of x in some intermediate values means in between x0 and x1, or it may be in between x1 and x2, or we can say more precisely we can say, suppose if we want to find the value of y in some between some value x0 and xn, then those finding process or procedure is called what? Interpolation. Okay, so what is interpolation? Interpolation is finding the value of y or f of x for some intermediate values between x0 and xn. So this is our starting number x0, and ending number is what? Xn. So in between x0 and xn, we have some numbers x1, x2. For those, we know the values y1, y2, all these things. But except these values, we have some more numbers. So if we want to find the value of the function on those numbers, then that particular process is called what? Interpolation. So let us see what is the definition says. So interpolation is defined as the process. Okay, so it is a process of finding values of the function for any intermediate. You see, for any intermediate values between x naught and xn. Okay, so between x naught and xn, we have so many values. So for those values, if we want to find the value of y, then that particular process is called what? Interpolation. Now, what is extrapolation? Now, if the range is x naught to xn, now see, there are some numbers which are greater than xn, and there are some numbers which are what? Less than x naught. So for those values, if we want to find the function, that means if we want to find the value of y for some values which are less than x naught and some values which are more than x naught, then that particular method is called what? Extrapolation. So extrapolation means finding y for some values which are outside the range. Range means x naught and x naught and xn. So if we want to find some values of y outside the range, then it is extrapolation. And if we want to find within the range, that is x naught and xn, then that is what? Interpolation. Okay, now let us go to the operators. So we have three finite difference operator. One is forward difference operator, which is denoted by delta, and then shifting operator, and next one is what? Backward difference operator. So let us first try to understand what is forward difference operator. Okay, forward difference operator. So for that, let us take a function y equals to f of x, and let us take some numbers x naught, and then x1, x2, x3. So like this, xn. Okay. So when we explain the definition of interpolation, we have taken some numbers x0, x1, x2. We said that they are distinct numbers. Here also the numbers are distinct, but a little twist is there. In place of, our x1 will be x0 plus h. So what we did here? An increment. Our initial number is x0, and the next number is it x0 plus h. What is x2 then? x0 will be x0 plus twice h. So we have increased h more. It will be x0 plus thrice h. So in the same way, our last number will be x0 plus what? nh. So these are what? These are arguments. So values of x are arguments, right? These are all arguments. Now the function is what? Y equals to f of x. Okay, the function is y equals to f of x. So if we put x0, we will get f of x0, or we can denote it by y0 also. Now for the function x1 or for the point x1, we have f of x0 plus h. Okay, so from here to here we have taken h increase. From here to here again we have increased h. Here also we have increased what? H. So these are equidistant. Here the arguments are equidistant. Okay, so they should be equal. Otherwise we can we don't get what? Forward difference operator. So for forward difference operator, all the arguments should be what? Equidistant. So for this particular number, we have x naught plus twice h, then x naught plus thrice h, and it is f of x naught plus what? nh. So this one we can denote by y1, this is y2, y3, and last one is what? Yn. Okay, so we have some equidistant arguments and some entries. See, the entries may or may not be equal. Okay, it will depend on the function, but the arguments are equidistant. Now, if we take the difference of y naught from y1, so means I am talking about what? Y1 minus y naught. So y1 minus y naught is the difference between two entries. This difference is called forward difference. Okay, first order forward difference. This is denoted by delta y naught. Okay, delta y naught. First difference, because the power of delta is 1. So first difference. The same thing. See, what is y1? Y1 means delta, sorry, y1 is our f of x naught plus h minus y naught is what? F of x naught is equals to what? Delta f of x naught. Okay, delta y. So in terms of f, if you write, it will be like this: f of x naught plus h minus f of x naught is equal to delta y, delta f of x naught. Or in terms of y, if you want to write, then it will be y1 minus y naught. Y1 minus y naught is what? Delta y naught. So this is called first difference. So what is y2 minus y1 then? Y2 minus y1 will denote it by delta y1. So this is another first difference, first order difference. So similarly, yn minus, what is the previous entry just before yn? It will be yn minus 1. So this will be denoted by delta yn minus 1. So these are all first order difference. Okay, these are all first difference of orders. Uh, first differences. So here this delta, no, this delta is called forward difference, forward difference operator. Okay, delta is forward difference operator, and delta y naught, delta yn, these are all first order differences. Now, now if we take the difference of first order differences, so I am talking about delta y1 minus what? Delta y naught. So delta y1 minus delta y naught will be our second order difference. So it will be denoted by delta y naught. Okay. Similarly, what is delta y2 minus delta y1? This will be our delta square y1. So these are second order differences. So in the same way, you can find third order also. Suppose delta square y1 minus delta square y0. So it will be delta q y0. So this is what? Third order difference. Third order difference. So in the same way, we can find up to any number of order. Okay, delta 4, delta 5. So whatever up to what power we need, we can easily find it. Okay, so is it clear? So first we have taken some equidistant values x0, x1, x2, then dot 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 xn, and the corresponding values are y0, y1, y2, y3. So these are all entries. So difference between two consecutive entry is first order difference. To denote them, we use delta, and that particular delta is called what? Forward difference operator. Okay. So we can make a difference table also. You see, suppose these are some arguments: x0, x1, x2, x3, and then suppose f of x, or you can write y or f of x, anything you can write. These are entries. So corresponding entries are suppose y0, y1, y2, and what? y3. So you can take more also, no problem. So first order difference, delta y0, or you can write simply delta y, delta y. So how to find delta y? This minus this. So let us write it in between. So it will be y1 minus y0. So y1 minus y0, how we denote it? Delta y0. Then y2 minus y1. So y2 minus y1 will be denoted by delta y1. Then y3 minus y2. So it will be our delta y2. Now second order difference, delta square of y. What we'll do now? We'll take the difference of first order differences. So means delta y1 minus delta y0. So delta y1 minus delta y0 is delta square y0. And if we subtract delta y2 minus delta y1, this will be our delta square y1. So one more we need delta q y. So third order difference will be what? The difference between two second order, means delta square y1 minus delta square y0. So this is delta square y0. Okay. So up to how much order we have to find? You just see here. 4 entries are there, no? Since 4 entries are there, so you have to go one less, that is up to third order. So if there are 5 arguments, then up to fourth order we have to find. Okay. So let us take an example depending on this difference table, then you'll understand that it's very simple. So here I have taken a problem. You see u0, u1, u2, u3, these are given. So here the function is not f of x, here the function is ux. Okay, u suffix x. So if we make the table, so can you tell me what are the values of x here? If you observe it carefully, suffixes, some suffixes are given. You see 0, then 1, then 2, and see, you observe that these are all equidistant. First is what? 0, then 1, 2, 3, 4, and one more, 5. So these are all, what is the difference between any two number? Is 1. So here the difference means I'm talking about h. Na? What is, the difference is, the interval of difference is h here. So h equals to how much here? 1. Then ux means the corresponding values of the entries. So these are given. So for 0 what is the value? 3. For 1 what is the value? 12. So we have to write like this: 3, 12, and 81, 200, 100, and our last number is what? U5 is how much? 8. So U5 is 8. So how many values of x are given here? 6. So we have to find up to fifth order. So that is what we need to find here. We need to find the fifth order difference, and we have to show that it is 750. So let us find the first difference, delta ux. So how to find delta ux? 12 minus 3. So 12 minus 3 is how much? 9. Then 81 minus 12, 69. 200 minus 81, how much it is? 119. Then 100 minus 200, so it is minus 100. And then finally 8 minus 100 is minus 92. So we are getting first order difference. Now if you observe first order difference, you are getting how many terms? 5 terms. So one is reduced because since we are subtracting now, so arguments are 6, but the first order difference is what? 5. Now let us make second order difference. So here we will get one more, one less term. Same process, 69 minus 9, 60, 119 minus 69. How much it is? It will be your 50. Then minus 100 minus 119. So it is minus 219. And then minus 92 minus 100. So minus minus it will become plus. So how much we will get? We will get 8. Okay, 8. Now let us go for third order difference, delta square ux, delta cube ux. Same process, 50 minus 60 is minus 10. Then this minus this will be your minus 269. And then 8 minus, so it will be your 227. Now see, in each step the values are reducing, right? Now we have only 3 values. So delta to the power 4 ux. So again 269 minus 10, it will be how much? Minus 269, no? Minus 269 minus minus plus 10, so it is minus 259. 227 minus minus plus, so you will get 496. And then the last one, delta to the power 5 ux. So finally if we subtract these two, we will get 755. See, this is our answer. We have to get delta to the power 5 ux is how much? 755. You see the problems are very simple, right? You just keep subtracting. Okay, so if you do the calculation properly, so we'll get the answer. Now let us go to the next operator, which is called shifting operator. So shifting operator is another finite difference operator. Here the in forward differential operator, we use the delta. Here we'll use e. So what is shifting difference operator? So e f of x. Okay, f of x is the function. So if we shift it, it will shift to 1 up to the next number. So when we take e f of x, see the power of e is how much? 1. So we have added 1h. So if it is e square second order, then how much it will be? F of, now we have to add 2h. What is h? H is the interval of difference. I think you know is x naught, then x naught plus h. These are some equidistant values, right? So the in each step the increment is what? H. So this h is called interval of difference. or you can say step size. Step size. That means in each step it is increasing h. So this will be our what? F of x plus twice. So in the same way, if you find e to the power n f of x, so it will be our f of x plus nh. So we have to add nh, right? So negative power also you can find e to the power minus 1 f of x. So how much it will be? E to the power minus 1. So you have to subtract 1 h. Then e to the power minus 2 f of x. It will be your f of x minus twice h. Then e to the power minus n f of x. So it will be our f of how much? X minus nx. So shifting property is very simple. Just shift it by looking into the power of e. Okay. If the power of e is 1, then we have to add 1 h. Suppose e f of x plus h. So already 1 h is there, right? Now we have to shift it with one more. So now it will become x plus twice h. Suppose e cube f of x plus twice h. So see, already twice h is there. So we have to shift it 3 more. So it will be f of x plus 5h. So it is like this. Is it clear? E to the power minus 4 f of suppose x plus 5h. So already 5h is here. We have to reduce it to minus 4. So this is f of x plus 5h minus 4h. How much it is? Plus h. So like this we can shift any function up to any order. Now let us go to the next operator, which is backward difference operator. So backward difference operator is denoted by what? Nabla. So nabla f of x. So our nabla f of x is f of x minus f of x minus h. Or you can denote it by nabla y naught also. No, y naught we can write y nabla y. Okay. So when you can write y naught, if suppose it is x naught. So what is nabla f of x naught? It will be our f of x naught minus f of x naught minus h. Then we can write nabla y naught. Similarly, what is nabla f of x naught plus h? So it will be your f of x naught plus h minus f of how much it is? Just think a little bit. It will reduce, no? We reduce by 1h. So it is x naught. This one we can denote by nabla y1. Now we have two backward difference operator. Nabla y1, two first order. These are first order backward difference operator. Backward difference operator. So here this nabla is called backward difference operator. Backward difference operator. Okay, nabla is operator, and this nabla y0, nabla y1, these are first order backward difference. So, operator no need. Nabla y0, nabla y1, these are first order backward difference, and nabla is backward difference operator. Now if we take the difference between first order, just like the forward, nabla y1 minus nabla y0. So this will be your second order operator, second order difference. So it will be nabla square y0. Okay. So nabla square y0 is what? Second order difference, backward difference. So similarly, if nabla y2 minus nabla y1, if we subtract these two, how much we'll get? We'll get nabla square y1. So these are all second order backward difference. So if we subtract second order, that is nabla square y1 minus nabla square y0, then we'll get third order backward difference. Third order backward difference. So is it clear? So it's very simple. Okay. So now let us go back to establish some relation. Okay. Now till now we have three operators, right? Delta. So what is delta f of x? Our delta f of x is f of x plus h minus f of x. Then we have shifting operator e f of x. So e f of x is, this is very simple, just increases by 1h, and then backward difference operator where we wrote f of x minus what, f of x minus h. So these are the three different operators and their relation formulas we know. Now let us find some relation between these three relation. Okay, first suppose relation between delta and a. So let us try to find a relation between delta and a, and this relation is very important. In so many places we have to use this, the relation between delta and a. So we have delta f of x. So what is our delta f of x? So delta f of x is our f of x plus h minus what, f of x, right? Delta f of x. Now see what is f of x plus h. You look at this one, this particular. Okay. So f of x plus h, this f of x plus h, what you can write? F of x plus h, you can write e f of x minus f of x. So you can take f of x common, e minus 1 f of x. Our left side is delta f of x. If you observe left side and right side carefully, here f of x is any function, any arbitrary function. So you already know that if f of x equals to suppose g of y, then we can write what? X equal to y. Okay, we are not cancelling f and g, but if two functions are equal, so here f of x is what? An arbitrary function. So if we, for any arbitrary function, this particular relation is what? Uh, for any arbitrary function, this particular relation will satisfy. So if we, since it is for any arbitrary function, so without the function also, we'll get to the same relation. So it's delta equals to how much? E minus 1. So this is the relation between, here we have to write, since f of x is arbitrary. Arbitrary means what? It may be any function, f of x, g of x, some sine function, some log function. It may be any function. Okay. So that's why we have written f of x is arbitrary. So finally, what relation we have then? Delta equals to e minus 1, or you can write e equals to 1 plus delta. So this one is the relation between delta and e. There are some other relations also. Let us prove one more. Now suppose a relation between nebula and e. So let us try to establish a relation between nebula and e. So what is nebula f of x? So nebula f of x is f of x minus f of x minus h. So you already know that what is e f of x? Our e f of x is f of x plus h. Then what is e to the power minus 1 f of x? It is f of x minus h, right? So f of x minus. So in place of this f of x minus h, we can write e power minus 1 f of x. So like the previous one, we can take f of x common. Now see our left side is nebula f of x. If we look at both sides, again f of x is arbitrary function. For any arbitrary function, this relation will satisfy. So we have nebula equals to 1 minus e to the power 1. Or you can write e to the power minus 1 equals to 1 minus nebula. So this is the relation between shifting operator and what? Uh, Backward difference operator. So like this, we have some other relations also. Okay, so you can prove any kind of relation. So if I keep proving all the relation, then this video will be a little bit more, okay, or it will be a little bit lengthy. So let us stop here. So in the next lecture, since we have three operators, delta, nebula, and e, so we'll try to do some examples depending on this particular three operators. Okay, so I hope finite all the finite difference operator is clear to all of you. Okay, and thank you for watching. So if you like it, then kindly share it with your friends.